Understanding intercourse, what happens during sex?
Sexual intercourse, or copulation, is a complex biological process involving a coordinated interplay of physical and chemical events that ultimately lead to the potential for reproduction. While often simplified to its physical act, a sophisticated cascade of physiological changes occurs at microscopic and macroscopic levels in both partners. Physical processes. The physical aspects of intercourse involve a series of observable actions and internal bodily responses. Arousal and engorgement, male. Sexual arousal in males triggers a parasympathetic nervous system response. This leads to the release of nitric oxide, NO, in the penile arteries, causing vasodilation. Blood flow to the corpora cavernosa, erectile tissues of the penis, dramatically increases, trapping blood and causing the penis to become engorged, rigid, and erect. The ischiocavernosus and bulbospongiosus muscles also contract, further contributing to and maintaining the erection.
Arousal and lubrication, female. Female sexual arousal also involves parasympathetic activation, leading to increased blood flow to the clitoris, labia, and vaginal walls, causing engorgement and height and sensitivity. A crucial physical process is vaginal lubrication. The increased blood flow to the vaginal walls causes transudation seepage of fluid from the capillaries, creating a lubricating fluid. Additionally, the Bartholin's glands, located near the vaginal opening, secrete mucus, further aiding lubrication and reducing friction during intercourse. The clitoris, homologous to the male penis, also becomes engorged and more prominent.
Penetration. The erect penis is inserted into the lubricated vagina. This act requires coordination and can be facilitated by various positions. Friction and stimulation. During intercourse, the rhythmic movements of the penis within the vagina create friction. This friction stimulates nerve endings in both the penis and the vagina, particularly the clitoris. This sustained stimulation is critical for escalating arousal and leading to orgasm. Orgasm, male, ejaculation. As stimulation intensifies, the sympathetic nervous system takes over. This culminates in ejaculation, a two-phase process. Emission. Sperm from the epididymis are moved into the ejaculatory ducts, where they mix with fluids from the seminal vesicles and prostate gland to form semen. Expulsion. Rhythmic contractions of the bulbospongiosus muscles at the base of the penis forcefully expel semen through the urethra and out of the body. The internal urethral sphincter also contracts to prevent urine from mixing with semen.
Orgasm, female. Female orgasm is characterized by rhythmic contractions of the pelvic floor muscles, including the pubicochaetus muscle, and the walls of the uterus and vagina. These contractions, often described as intensely pleasurable, are a result of sympathetic nervous system activation following sustained clitoral and vaginal stimulation. While not directly linked to reproduction in the same way as male ejaculation, orgasm can enhance sperm retention due to uterine contractions and may contribute to overall reproductive success by promoting bonding.
Resolution. Following orgasm, both partners enter a resolution phase. Blood flow to the genitals decreases and the erectile tissues detumesce. Muscles relax and the body returns to its pre-arousal state. Males typically experience a refractory period during which they are unable to achieve another erection and orgasm. Chemical processes. Underlying these physical actions are a myriad of chemical processes involving hormones, neurotransmitters, and other biochemicals. Neurotransmitters in arousal.
Nitric oxide.
As mentioned, NO is a key chemical mediator of penile erection. It is released by nerve endings in the penis and acts as a potent vasodilator, relaxing the smooth muscles of the penile arteries.
Acetylcholine.
This neurotransmitter also plays a role in parasympathetic activation and vasodilation in both sexes.
Dopamine.
Often associated with pleasure and reward, dopamine levels increase during sexual arousal and activity, contributing to the pleasurable sensations.
Norepinephrine noradrenaline.
While involved in general arousal, high levels of norepinephrine can inhibit erection. However, during orgasm, it plays a role in smooth muscle contractions leading to emission and expulsion.
Serotonin.
This neurotransmitter has a complex role, with some serotonin pathways inhibiting sexual function and others being involved in the resolution phase. Selective serotonin reuptake inhibitors, SSRIs, common antidepressants, often have sexual side effects due to their impact on serotonin. Hormones. Testosterone.
While primarily a male hormone, testosterone is present in both sexes and plays a crucial role in libido sex drive in both men and women. It influences the sensitivity of sexual organs and overall sexual desire.
Estrogen and progesterone.
These female hormones fluctuate throughout the menstrual cycle. Estrogen contributes to vaginal lubrication and the health of vaginal tissues, while progesterone levels rise after ovulation. Their balance impacts female sexual responsiveness.
Oxytocin.
Often called the love hormone or bonding hormone, oxytocin is released in large amounts during orgasm in both men and women. It promotes feelings of attachment, trust, and well-being, playing a significant role in postcoital bonding. It also contributes to uterine contractions during female orgasm.
Prolactin.
Levels of prolactin rise significantly after orgasm, particularly in males, and are thought to contribute to the post-orgasmic refractory period and feelings of satiety. Vaginal pH. The chemical environment of the vagina is typically acidic pH 3.8 to 4.5, which helps protect against infections. During arousal, vaginal lubrication increases, and the pH may temporarily become slightly less acidic, which can be more favorable for sperm survival.
Semen composition. Semen is a complex fluid with a specific chemical composition designed to facilitate sperm survival and transport. It contains fructose, provides energy for sperm motility, prostaglandins. These compounds in seminal fluid can induce contractions in the female reproductive tract, potentially aiding sperm transport towards the egg. They may also suppress an immune response in the female reproductive tract. Zinc. Essential for sperm stability and fertility. Citrate. Acts as a buffer to maintain pH. Spermine and choline. Contribute to the characteristic odor of semen.
In summary, sexual intercourse is a remarkable example of integrated biological function. From the initial psychological triggers of arousal to the final resolution phase, a sophisticated interplay of physical mechanisms and precise chemical signaling ensures the potential for reproduction and fosters pair bonding, highlighting the intricate beauty of human physiology.
Thanks for watching.